Today I'm going to talk to you about the intermediate value theorem, more commonly known as IVT. The intermediate value theorem states the following. If a function is continuous on a closed interval from A to B, and y is a number between f of A and f of B, there exists a number C in the open interval A to B such that f of C equals y. So if a function is continuous on a closed interval A to B and y is a number between f of A and f of B, there exists a number C in the open interval A to B such that f of C equals y. So what this looks like, maybe you wrote smaller than me and didn't run out of space, but I'm going to draw a little coordinate plane. Let's say, you know what, we don't need that big of a coordinate plane. Let's just do the first quadrant here, and let's say we have a function that does that. Let's pick a couple points. Let's say that first point is A, f of A, and that point is B, f of B. So IVT states that assuming this function f is continuous on the closed interval between A and B, so no holes there, there exists some C such that f of C is between f of A and f of B. Okay, so if the function's continuous on the x between the x values A and B, then there has to be some C that falls between the y values. That's the gist of it. So we'll look at these graphs, and we'll see if IVT applies. That's the key, is looking for if IVT even can be used. So first, is there a value of C on -5 to 2? So -5 to 2 is going from here to here, such that f of C equals 2. Is there a spot where f of C is 2? Looks like it. Yes. YEC, I'm combining things. Yes. C would be approximately -4.5. Now we're saying, does IVT guarantee that? Does IVT say that there has to be some f of C that equals 2 on that interval from -5 to 2? And the answer is no. So no IVT, because f is not continuous on the closed interval from -5 to 2. So that's always what you check first. Is it continuous on this interval we're talking about it? Since no, IVT doesn't apply. Was there a value? Sure, but IVT didn't guarantee it. For the next one, same graph, we're looking for a value of C on the interval from -1, again the intervals are x's, to 5. So is there a value such that f of C is 2? No. Does IVT guarantee it? I mean, hopefully not, because it doesn't exist, right? But let's see. So it's continuous, but now let's look at our x and y values. So our interval goes from -1 to 5. So those are our x values. And over here for y, well, f of -1 looks like about negative 0.5. And f of 5, if we continued it, looks like maybe negative 3.5. And so what we're looking for is right in here. So we're looking for, does 2 fall in between negative 0.5 and negative 3.5? And no. So no IVT. That's my cat, Chester. No, please don't rub your face on everything right now. Sorry for the interruption. No IVT because 2 is not between negative 0.5 and negative 3.5. So, what conditions must be true to verify whether IVT applies? First one, f of x must be continuous on a closed interval, and that closed interval is x values. You may hear one of my children crying in the background. I'm not sure how well these headphones work. The other piece is that f of a has to be less than f of c, which has to be less than f of b. And our y is f of c. This is just saying f of c has to be between f of a and f of b. So if we look at the first one here, first question, is it continuous on the interval from negative 1 to 3? Well, if we look at this, it's only discontinuous when x equals negative 2, when the denominator would be 0. So yes, it's continuous. X can't be negative 2, but that's not even on that interval, so we don't care. Second piece, let's look at our x and y values. So our interval goes from negative 1 to 3. F of negative 1 is going to be negative 4 over 1, which is negative 4. F of 3 will be 3 minus 3, which is 0, over 5, which is 0. So we're looking right in here. And we're looking to see if 2/3 is in between negative 4 and 0. And it's not. 2/3 does not fall in between those values. So no IVT because 2/3 is not between negative 4 and 0. For the next one, first question is always continuous on the interval, in this case negative 4 to 1. Let's see, well, it's the same function as before, so it's not continuous at negative 2. And since negative 2 is between negative 4 and 1, it's not continuous on the interval. So no IVT because f is not continuous on the interval from negative 4 to 1. Okay, let's look at this third one. Again, our first step, is it continuous? So continuous on the interval from negative 1 to 1. Well, let's see. It looks like it's, if you look at the denominator, that's really for a lot of these, you're looking at where the denominator is 0. You're really just looking for any value that doesn't work in the function that you can't produce a y value from. So it's discontinuous at x equals 2, and that's fine because it's not on negative 1 to 1. It's not on that interval of x values. So yes, it's continuous. X just can't be 2. So now we're looking at right here. So our interval was negative 1 to 1. So we always leave that gap in the middle. F of negative 1 is going to be negative 1 over negative 3, which is 1/3. F of 1 is 1 over negative 1, which is negative 1. And so we're really just looking at if negative 1/2 is between 1/3 and negative 1. And since 1/2, negative 1/2 falls in between there, we're good, okay? Since 1/3, basically if you travel from a y value of 1/3 to a y value of negative 1, you'll pass negative 1/2. And so then, yes, IVT applies. We're skipping this one over here, so if you write big like me, you can use this space too. Because 1/3 is less than negative 1/2. You know what? Forget that. Think of it as between. Negative 1/2 is between 1/3 and negative 1. Our third step, when we get to it, is to find our c. So find what the x value would be. So basically we want to know when that function x over x minus 2 is equal to negative 1/2. And so then if we just cross multiply, we'll get x times 2, which is 2x, equals negative 1 times x minus 2, which is negative x plus 2. And we end up with 3x equals 2. Divide by 3. X equals 2/3. But really we call it c if you answered x equals 2/3. It's kind of okay, but try to be consistent and say c equals 2/3.